Dear learners, now we are in a new video. It's on hands-on practice of computation of standard deviation. We have two videos regarding standard deviation. This is the first video. Let us enjoy learning. What is actually standard deviation? You must have listened to the previous lecture that talks about what is standard deviation. It is one of the measures of dispersion, right? It is considered as the best measure of dispersion. Why it is considered as the best measure of dispersion? Because it is used for all the other statistical calculations. It is used for further statistical calculations. When you go for regression, there is an element of standard deviation. When you have to do compare means through ANOVA, independent sample t-test, paired sample t-test, we have to go for standard deviation as well. How do we define standard deviation? It's a layman's definition. Square root of arithmetic mean of squares of deviations of observations from their arithmetic mean. It's very clear what is standard deviation. It is the square root of arithmetic mean of squares of deviations of observations from their respective arithmetic mean. See, this is another definition of standard deviation. Standard deviation is a static. It is a static that measures the dispersion of a data set relative to its mean, and it is calculated as square root of the variance. You know variance? Variance, the square root of variance is standard deviation. Square of standard deviation is variance. Got an idea what is standard deviation? It is the square root of arithmetic mean of squares of deviations of observations from their arithmetic mean. So let me write the definition of standard deviation as a formula. Shall I write? See, it's very clear. Whatever it is written, let me write it through what we call it as, let me symbolize it through the equation. Square root of standard deviation is square root of arithmetic mean is sigma something by n. Arithmetic mean of squares of deviations of observations from their arithmetic mean. This is the equation. Let me make it more clear. This is the thing. Square root of arithmetic mean of squares of deviations of observations from their arithmetic mean. Now see the equation. There are different equations. Some of the symbols used are different. This is mu. You know, mean is mentioned by this mu. The same is mentioned in the second equation as x bar. Somewhere you can mention arithmetic mean as well. Arithmetic mean, x bar, mu, everything is same, right? This is also same. So whatever it is, the way you use, you can use it in the equation. So remember the equation. Standard deviation is mentioned through small sigma. This is small sigma. Sometimes we use this is the way of representing small sigma. Clarity, you got a clarity, right? See, this is simple for standard deviation. Okay, so let me rub the other two. Clear? So standard deviation is square root of arithmetic mean of squares of the deviations of observations from their respective arithmetic means. Okay, clear. Now the concern again, like any statistical calculations, we have two cases of calculations. One is for an ungrouped data, that is raw data, and second is for a group data. So let us come to an ungrouped data. Computation of arithmetic mean for a raw data. This is raw data, ungrouped data. Is it clear? Okay. Now let us come to computation of standard deviation for this. So for the clarity, I'm writing again the equation. What is it? Standard deviation is square root of arithmetic mean of squares of deviations of observations from there. This is the equation for raw data, standard deviation. Shall we make it? So this is the value set we have. Now for the clarity, what is the requirement in the equation? See, what are the requirements? Sigma, it is total that we know. X is individual observation. What is X? X is individual observation. 2 is an X, 4 is an X, 5 is an X. So everyone is individual observations or individual scores. Clear? What is X bar? You know that X bar. X bar is arithmetic mean, right? How to calculate X bar? We have to have an idea regarding how to calculate arithmetic mean. What is this? Arithmetic mean of an ungrouped data is sigma x by n. Total of the observations divided by number of observations, right? It is sigma x by n. Am I right? Yes, sigma x by n. Then what is needed extra? N, right? N is total number of observations. Total number of observations. Clear? All the terms we have. Then we have square and square root divided by. These are the operations, right? Yes. Now let us compute standard deviation for the raw data. We have a raw data set 2, 4, 5, 6, 8, 9, 6, 0. How many observations we have? 2, 4, 6, 8. Number is 8. N is 8. Clear? Let us come to calculation or computation now. There will be some calculation part I will drop for you. For example, square root. I am not going to do the square root for you. You have to compute. These are simple operations. You can do that, right? Yes. Come to the requirements. This is the equation. So what first we need to identify? What first we need to identify? Yes, we have x. Next is x bar. We don't have an idea about x bar. What is x bar? X bar is arithmetic mean. It is sigma x by n. So shall we do that first? In this only we are doing that. Is it okay? Yes. Go for calculation of arithmetic mean. 2 plus 4, 6. 6 plus 5, 11. 11 plus 6, 17. 17 plus 8, 17 plus 8, 25. 25 plus 9, 34. 34 plus 6, 40. 40 plus 0, 40. So, sigma x I got is 40 and n is 8. What is arithmetic mean? X bar or arithmetic mean. What it is? Sigma x by n. How will you go for that? Sigma x we got it 40 upon number of observation. It is 8. Am I correct? Yes. What is the answer? 40 by 8, 5. 5 is the arithmetic mean of the group. So simply from the simply using the equation for arithmetic mean for an ungrouped data, we calculated arithmetic mean firstly, initially. Got it? You got an idea. How do we do? Yes. Add the observations divided by number of observations. Very clear. Sigma x by n. Now, I have made it as a table for clarity for further calculations. What is the equation? Again, let me repeat the equation. Square root of sigma x minus x bar the whole square by n. So what we have to do? Just see. Okay. Let's see this. First, what is needed? X bar we have to calculate. Did you get X bar from the previous slide and calculations, we got x bar. What is x bar? It is 5. Let me take it here. That is, we got x bar. What is x bar? It is 5. Okay, we got x bar, that is 5. Now, x bar I mentioned here as arithmetic mean, AM. X bar can be mentioned as AM or mu. Another simple we have mentioned, right? It is mu. This is the way of representing arithmetic mean. Let me clearly mention it. Mu we mention. Otherwise, AM, arithmetic mean. We write all these. Okay. Now come to the computation part. How do we calculate arithmetic mean for the data set? See, now let us come to the computation part. How do we calculate standard deviation for the data set? So for a clarity, I just made all the observations here 2, 4, 5, 6, 8, 9, 6 and 0. I just taken it as a table for clearly mentioning the further calculations. So I made a table. So what I need is x I have mentioned here. Next I need x minus x bar. This is the thing, x minus x bar. I have mentioned x bar as arithmetic mean, AM. Next is x minus x bar the whole square. X minus x bar the whole square. These are the calculations I have to find out. Then what I do? Sigma. I will go for sigma of x minus x bar the whole square. After that, I will divide it with number. What is number? N is 8, right? N is 8, x bar is 5. We got everything, right? Now let me write the equation by filling each and every segment. First, x, we have arranged x. The x, you know that each one of the observations, they are arranged as x one by one for better calculation. See, second is x minus x bar. You have the value of x bar, it is 5. What is x here? First x is 2. 2 minus 5. What is the value? Minus 3. 2 minus 5, minus 3. 4 minus 5, minus 1. 5 minus 1. 5 minus 5, 0. 6 minus 5, 1. 8 minus x bar, that is 5. 8 minus 5, 3. 9 minus 5. You are getting the clarity. We are taking the difference between x and x bar, x and arithmetic mean. 9 minus 5, 4. Again 6 minus 5. What is 6 minus 5? 1. 0 minus 5, minus 5. I got all the x minus x bar now. Clear? Now what we need further? X minus x bar the whole square. X minus x bar the whole square. Let me come to x minus x bar the whole square now. See? Minus 3 into minus 3. That is square of 3. Of course, 9. Got it? 1 minus 1 into minus 1. 1. 0. It will be 0. 1. Again 1. 3. Square of 3 is 9. Square of 4 is 16. Square of 1 is 1. Square of minus 5 is 25. I got all the square of x minus x bar. That is x minus x bar the whole square. Once again, what we have done? Arrange the observations in a tabular format to write the further part of the calculation. We have seen sigma x by n, that is arithmetic mean. What we got it in the previous slide we have done? 5 is arithmetic mean. Now we have moved towards next calculation, that is x minus x bar, x minus arithmetic mean. We got minus 3, minus 1, 0, 1, 3, 4, 1 and minus 5. Now again the second part of the calculation, that is x minus x bar the whole square. Minus 3 the whole square 9, minus 1 the whole square 1, 0, 1 square 1, 3 square 9, 4 square is 16, 1 square is 1, and minus y the whole square is 25. Now what I need, see the equation, x minus x bar the whole square, I got it. X minus x bar the whole square, I got it individually, right? This is x minus x bar whole square for the first observation. Likewise, all the 8 observations, for all the 8 observations, I got the value for x minus x bar the whole square. Now, the entire numerator in the equation, sigma of x minus x bar the whole square, when you compute this total, you will get sigma of x minus x bar the whole square. X minus arithmetic mean the whole square you are getting, right? Let us add. 9 plus 1, 10. 9 plus 1, 10. 10 plus 10, 20. 20 plus 16, 36. 37. 37, 57 and 62. 62 is the sigma of x minus x bar the whole square is 62. See whether it is correct. 10, 11, 11 plus 10, 11 plus 9, 20. 20 plus 16, 36, 37, 62, right? Am I right? 62. So now let me apply. I got sigma of x minus x bar the whole square I got. What is the equation? I'm just applying. Standard deviation is square root of numerator we got, denominator also we got. Sigma of x minus x bar the whole square. 62 divided by what is n? 8. Again expanding, what it is? 62 by 8. 56 is 7, right? 7 point, what is the rest reminder, what is it? 6. Out of 6 it is 8. 56, right? Again we have 4, 5, right? This is the calculation. This is the value that we got. Square root of 7.85. Okay, calculate now. It is your turn. Now calculate. It's very simple, isn't it? Yes. First, we are writing the observations. We are going for arithmetic mean. Difference between the observation, each observation and arithmetic mean. Just take the square, that is x minus x bar the whole square. Calculate the total, that is sigma of x minus x bar the whole square. Then apply it in the equation. The only requirement is, other than this, n. N is total number of observations. So what we have done here, we have taken sigma of x minus x bar the whole square 62 divided by 8. I got the value 7.85. Am I correct? Yes, correct me if I am wrong. Now it is your turn to write the original value. Just go for square root and find out what value you got. You can add it to the discussion forum whether you got the specific answer or not. Got it? This is the simple way of calculating standard deviation for an ungrouped data. Yes, now you can practice. This is a question for you. How to do standard deviation for this data set? This is an example for you. For a clarity, let me repeat again what you have to do. What we have to do again, let me write. We are writing the x one by one, right? I'm helping you to write down now. 12, 14, 15, 17 and 22. What is next? Yes, x minus x bar. X minus x bar. What is next? X minus x bar the whole square. But x bar is missing. So you have to go for sigma x, then you have to go for sigma x by n. That is x bar, right? What is n? Sigma x you have to identify, and you are taking n as well. What is n? 1, 2, 3, 4, 5. N is 5. I'm not doing for you. I just mentioned the basic steps of calculation. I hope that you can do that. Am I correct? Yes, you can do that. It's very simple. We have already learned in the previous classes of theory and computation of arithmetic mean how to compute arithmetic mean. This was simply replacing it with, this was simply taking the same concern to standard deviation. Now, based on the arithmetic mean, we have calculated further steps of standard deviation. X minus x bar and x minus x bar the whole square. Then we have to go for standard deviation equation. Why I write repeatedly? To confirm. For your learning, it is essential. Square root of sigma of x minus x bar the whole square upon n. Calculate it and post it in the discussion forum for sure. I hope that you can do, right? Yes, now, frankly, assess yourself. Have you achieved the learning outcome? What was the learning outcome we have intended to achieve at the end of the video lecture? What was the learning outcome we have intended to achieve at the end of the learning practice? What was the learning outcome that we have intended to achieve at the end of this video lecture? Yes, you have to get the ability to practice and compute standard deviation for an ungrouped data. Could you achieve it? I hope that you could. Yes. If not, if you have not clearly watched the video, once again watch the video. It is a good learning exercise. Yes. Standard deviation is being used for further calculation. It is the best measure of dispersion. Definitely, you have to practice it. All the best. Have a happy learning. Thank you.